Hello everyone. Today let's get through to the basic operating skills of shielded metal arc welding, arc ignition, electrode movement, weld connection, and finishing. The focus of this class is to master the basic skills and operation essentials of arc ignition, electrode transportation, weld connecting, and finishing. First, let's learn the operation of arc ignition. What is arc ignition? In electro arc welding, the process of igniting the welding arc is called arc ignition. When starting the arc, two conditions must be met at the same time. One is that there must be two electrodes, and the other is that there must be a certain current and voltage between the two electrodes. Next, let's learn the operation of arc ignition. Safety first. Before the arc striking operation, it is necessary to wear labor protection equipment correctly. Clean up the workplace without inflammable and explosive materials. Check whether the wiring between the welding machine and the welding tongs is firm. Prepare protective masks and other tools. The arc ignition method of shielded metal arc welding is contact arc ignition. That is, the welding rod is in contact with the weldment first, so that the welding circuit is shortened, and then the electrode is quickly pulled away to ignite the arc. According to different operation methods, the arc ignition method of electro arc welding can be divided into two types: direct strike method and scratch method. First, let's introduce the direct strike method, which is to make the electrode and the surface of the weldment in vertical contact. When the end of the electrode touches the surface of the weldment lightly, the electrode is quickly lifted and the distance of 2 to 4 millimeters is maintained. The arc can be ignited. When operating, you must master the time and distance of the up and down movements of the bowl. The second is the scratching method. Find the arc striking point firstly, then align the end of the electrode with the arc striking place, and then scratch the electrode on the surface of the weldment lightly like a match. With a scratching distance of 10 to 20 millimeters, the arc can be ignited by lifting the electrodes by 2 to 4 millimeters. During operation, force shall be applied by hand to make the welding rod move, and the range of movement shall be small. When starting the arc operation, be sure to pay attention to the following points. First, you must wear a mask before starting the arc so as to avoid the arc light hitting your eyes. Second, if striking occurs, the electrode should be shaken left and right a few times quickly so that the electrode can be separated from the weldment. If the electrode cannot be separated from the weldment, the welding tongue should be loosened immediately, and the electrode should be cooled after the electrode is cooled. Take it down, otherwise the sticking time is too long and the welding machine will be burned out due to the long-term short circuit. Third, the used electrode has the end coating longer than the welding core, commonly known as sleeve. When striking the arc again, the sleeve must be removed first, so as to facilitate arc striking. Next, let's get through to operate the electrode movement. The so-called electrode movement is a general term for various actions performed by electrode relative to the weld during the welding process. It includes three movements. One is the feeding of the electrode to the molten pool along its center. The second is the movement of electrode along the welding direction. The third is the lateral swing of the electrode along the width of the weld. These three movements must be coordinated in order to weld beautifully formed and qualified welds. So, what are the common electrode movement methods? There are mainly the following 7 types. The first is the linear movement method, which means that the electrode does not swing laterally during welding, but only moves linearly along the welding direction. The second is the linear reciprocating method, which refers to the back and forth linear motion of the end of the electrode along the longitudinal direction of the weld. The third method is the zigzag movement method, which means that at the end of the electrode oscillates continuously in a zigzag shape along the welding direction and stops for a while on both sides. The fourth is the crescent shape movement method, which means that at the end of the electrode swing left and right in a crescent shape along the welding direction. The fifth is the triangle movement method, which means that the end of the electrode makes a continuous triangle movement and moves forward continuously. According to different ways of swinging, this method of transportation can be divided into two transportation methods: oblique triangle and equilateral triangle. The sixth is the circular movement method, which means that the end of the electrode makes a circular movement and moves forward continuously. The seventh is the figure 8 movement method, which means that at the end of the electrode continuously moves in the shape of Arabic numeral 8 and moves forward continuously. These shipping methods have their own characteristics and their respective application occasions. You should comprehensively consider personal habits and welding positions and choose the shipping method that suits you to master and use. Next, we will learn about welding bead connections. For a long welding scheme, generally several electrodes are needed to complete the welding, and each welding seam needs to be connected with a joint. Therefore, after each welding electrode is welded, when replacing the electrode, there is a connection point, and the location of this connection is the location of the weld connection. There are four ways of welding seam connection. The first is the head-to-tail method, which refers to the subsequent weld starting from the end of the previous weld. First, ignite the arc 10 mm before the arc crater of the previous weld. Then move back to the arc crater and slightly lengthen the arc. Drive the sling in the arc crater backward. Preheat the joint at the same time, and wait until the arc is filled after the pit. Depress the arc and switch to normal welding. The second is the head-to-head method, which means that the beginning of the two welds are joined together. It is required that the beginning of the front weld is slightly lowered. The arc of the latter weld is about 10 mm before the start of the former weld, and the arc is moved to the joint, and then the arc is slightly elongated to cover the end of the former weld. After the fusion is good, then normal welding. The third is the tail-tail method, which means that at the end of the two welds are joined together. When the subsequent weld is welded to the end of the previous weld, the welding speed should be reduced. After filling the arc crater of the previous weld, weld forward at a relative fast speed for a section and then extinguish the arc. The fourth is the tail-to-head method, which means that the end of the subsequent weld is joined with the beginning of the previous weld. It is required that at the beginning of the front weld is lowered, preferably inclined. When the back weld reaches the start of the front weld, change the angle of the electrode, change the forward tilt to the back tilt, and make the electrode point to the start of the previous weld. Beginning, lengthen the arc, and after the molten pool is formed, then lower the arc to return to the original molten pool to end the arc. The last thing we are going to learn is finishing of the weld. The end of the weld is not only to extinguish the arc, but also to fill the arc crater at the end to eliminate arc crater cracks. There are three ways to finish. The first is the circle method, which means that at the end of the electrode makes a circular motion until the droplet fills the arc crater, and then the arc is poured. This method is suitable for medium and heavy plates and alkaline electrodes. The second is the back welding method, refers to that when the electrode is welded to the end of the weld, stop the strip transportation but do not extinguish the arc. Change the electrode angle, turn the electrode from position 1 to position 2, turn to position 3 after the arc pit is filled, and then pull off the arc. This method is also suitable for medium and heavy plates and plastic electrodes. The third is repeat arc breaking method, which means that when the electrode is welded to the end point of the weld, the arc is repeatedly extinguished and arc struck on the arc crater until the arc crater is filled. This method is suitable for thin plate and spatial position welding. That's all for today's lesson. Thank you. Goodbye.